really I can't answer. So I will brainstorm with some experts and I will come back to the, to those people related to the questions. So as I would like to introduce myself again because we have some new, friends here today. So my name is Jawad Ali Khan, and I'm PhD petroleum engineering candidate at University of North Dakota. So North Dakota is actually the second largest oil producing state in the United States. They are producing approximately 1.2 million barrels per day, and they have drilled so far more than 16,000 wells. So it's a hub for the oil and gas, and also they're looking for the geothermal and other new projects as well. I completed my master's degree in petroleum engineering in University of North Dakota, and I worked for OGDCL for more than 9 years. And I am the current president of Society of Petroleum Engineers SP chapter. And I fortunately selected again as a president for 2024 as well. So actually, I became the president in 2022. I was also invited as seasonal chair and speaker by the World Congress Dalian China in 2020. And I presented many presentations regarding the big data management and artificial intelligence at the SP platform in Malaysia, China, and Pakistan, and the US. So this is something which I actually learned during my experience at OGDCL, and then attending different SP conferences, and then meeting with the people, and then brainstorming on different topics. So today I would like to just focus, like in the last 2-3 presentation, I remembered the questions I was asked about. So I will not, in this presentation, I will not jump into the details in the information, because in the previous sessions, we tried to give more information, what is artificial intelligence, how we can work in the oil and gas and companies on this topic, and how we can improve efficiencies, how we can make smart decisions, how we can integrate the data, what are the challenges, what is big data, what is data analytics, what is predictive analytics, what is diagnostic analytics, what is machine learning, what is supervised, unsupervised algorithms. So I think all people know it now, and I'm really glad that the people are getting interest in this topic day by day. So today I would like to just jump into the real-time examples. And before that, for the new people, I'm just going to go through all those slides just in, maybe 1 and 2 minutes. And then we will jump into the real-time, case studies and examples. So as I discussed in the first presentation, Asghar Saab, that what is the difference between digitalization right now we have and the digitalization before? So in the very simple words, that the data become digital in 1950s, which we call the industrial third revolution. But what is the difference between this digitalization we have today? And because in 1950s, the computer were invented and we used to digitize the data. So the main difference between this digitalization and the previous digitalization is that we have a massive amount of data nowadays. And why we have a lot of data? Because of the capabilities of the computer machine. So there are 3 basic laws of the computer machine: Kirdan's law, Bert's law, and Moore's law. They are saying that the capabilities of the computer machine have been increasing significantly every 6 months, 18 months, or whatever. So if we see the storage capabilities, the processing capabilities of the computer machine have been increasing. So what does it mean actually? It means that now we have the world, or the companies are now generating more data because of the computer machine. And now they can save more data. And now the question is that if we have a lot of data and we have now powerful computer machine, what to do with this data? So the answer is that how we can better understand our data sets, excuse me, and how we can actually manage this data to apply different algorithms and apply different machine learning techniques to properly manage the data and train these data set for machine learning, artificial intelligence system, and make smart decision. So this is one of the most important purpose of this whole presentation. So this digitalization means that we have now a massive amount of data, and now we want to place this data set in a digital platform, which we nowadays terminology we say cloud technologies. And after structuring the data, cleaning the data, saving the data, now it depends upon different professional. For example, if you are a drilling engineer, so drilling engineer understand very well what are the trends in the drilling data, what is happening actually in their drilling fields. what they are going to decide about the new wells, how to place new wells, and how they can predict their strata. And I have given real-time example of different companies. For example, ADNOC is working on different technologies to further break down the rock formation and zoom it out and see how they can efficiently drill the formation. So there are numerous examples like this. So this is the most important, objectives of digitalization. Then we talk about, let me just go straight away. The main objective is in the oil and gas industry is to better manage production. So once we have a good amount of data sets, and once we structure the data, once we clean the data, then we would be able to properly analyze the data and train it for the machine learning. There are different sort of machine learning algorithms, and then we can properly, make smart decisions. So actually all those informations which are not available properly on the cloud-based system in our storage, we want to make it properly save and on the cloud, and then analyze it and make smart decisions. So to increase the cost efficiencies, to make smart decisions, and then we talk about the big data analytics and augmented realities, cloud technologies. All those information are available on the internet. So I don't want to go into details again. And then very simple slide I discussed previously, that this is the industrial fourth revolution. So every revolutions, they just change the world, and they change the GDPs of the countries. If you see in 1760, the first revolution, second revolution, third revolution, and now fourth revolution. So you see the graph is very clear. The GDP has been increased, during these revolutions. So this artificial intelligence, it will bring more money to the world, and it will change the style working of the people. And the people are now working, moving towards another structure, and it will definitely affect some jobs, but it will also create new opportunities for the people. So it is important now for us, today we are in this presentation, to adopt all those things which can change, which will show us how to be part of this industrial fourth revolution. This is important, because if we remain here, it would be really very challenging for us to move forward in the future. So this was talk about the most important thing in this slide is there is a huge gap in the oil and gas industry, and there is exponential evolution in the technology. So the main objective is to fill this gap. Everyone who is here from different sector, excuse me, what we can do it is actually to minimize this gap, and this is our main objective. Then we talk about the big data analytics, big data, what is big data in oil and gas. Then we talk about the big data in details, structured data and structured data. Then we talk about the, the fourth V, the third V introduced by the IBM. Then what actually we call, what is volume, velocity, all those things we have discussed. And then we have given some real-time examples. Then what are the importance of big data in oil and gas is well planning, well integrity issues, improved health and safety, production optimization, and reservoir management are the major applications. Then big data analytics have different applications in upstream, midstream, and downstream. And then this is a real-time example that ISP, that how we can gather the data, we can properly analyze the data, we can understand the patterns, the correlation, and make meaningful and smart decisions instead of traditional decision making. And then this is the amount of data. As I earlier said, you can see if you go to the Google, it is very important trends that most of the publication they have been published on big data is after 2011, because the world been taking interest more in big data after 2008, 9, 10, 11 specifically. So the total volume of the data, if you see this graph, is very important. It shows that the data, the number of data have, the store is generating is significantly increased, and it would be 175 zettabyte by 2025. So this shows the more you have data, the more you expose yourself to the data, the more you are going to work on the data, and it will gives you more understanding how to manage this data and make smart decisions. So this graph actually shows, the generation of data, and it also shows the importance of data. We have now lots of data, but now this is the responsibility of every professional to deal with this data and use it for meaningful information. Then we talk simply about the data analytics. So descriptive analytics, diagnostic, predictive, prospective. So these are different, ways to understand the data. For example, you can study the historical data for, to understand the history and make some decisions. And now diagnostic examine the data to answer the question why it happens, and then predictive and so there are different sort of analytics techniques you can apply, and you can find out a meaningful information through it. Now this is the generation of the data, and as I earlier said, this is the old slide, but I would like to say it's like 2021 or 20. So 90% of the data in the world today has been created in the last 2 years alone. This is the main focus point of this presentation. So most of the data, they are recently generated because of the most powerful computer machines. And every minute 1.7 MB data is created by every person on the planet, and it's all about 7.3 billion, more than that. And industry spend 30% of time looking for the unstructured data. So in this presentation, I'm focusing again to focus on the major points. So the second important point is that the industry are spending 30% of the time looking for the unstructured data. So what this revolution will give us actually to manage the data and reduce the time for searching the unstructured data. Once you structure the data, you can easily approach the data and you can make smart decisions. So the major application of this artificial intelligence systems are actually the big data or analytics is to actually properly manage the data. But this is a very important point that the oil and gas companies are spending 3 times more than other industries. But we are different from other industry because the oil and gas industry is expending more time. You can say more than 30%.
Jawad,
Yes.
I want to ask one thing here, if you can, for a second.
Yes, sir.
This unstructured data you are mentioning, are we converting the unstructured data into structured data, or we just use it like unstructured?
No, Farooq Sahib, it is important to convert the unstructured data because, let me go back. So, I mean, we have to understand the 5 views of the data. And for example, if we talk about the big data, so we know what sort of data we have. So if we don't know exactly for example, if the data is not very clean, if the data is not very, properly organized, so I think it wouldn't be somehow give us a true, for example, one of the company, they are working on digitizing the oil and gas data. So they are digitizing the 1950s logs data. So in the coming example, I will show how a company is actually going to structure. Actually, they structure the data and they apply it for machine learning algorithm. So my point of view is that indeed, definitely, we need to make this unstructured data actually to clean it out and make it structured.
Okay, that's good. Thank you.
Thank you, Fauza. So in drilling operations, a single rig produces terabytes of data every day. There are approximately 80,000 sensors in modern offshore drilling platform that generate approximately 15 petabytes, 15 million gigabytes of data during an asset lives. So now this is the data, the amount of data. For example, if we are looking to the offshore drilling rig, so we have a lots of data, we have sensors, but now what to do with this data is the main question. And then I simply talk about the big data technology challenges and opportunities. Several companies are dealing with the massive amount of data. As I discussed, one of the main applications of big data is to process, analyze the increasing amount of data. I discussed the main advantage of big data technology is that it provides business values such as cost reduction, decision making, and enhanced products and services. Most database management systems are huge and are designed for systematic transaction processing, aiding, updating, searching, and extracting a limited amount of information. So this is very important point. Some companies, they have a very good amount of, for example, in OGDCL, for example, let's suppose I don't want to make like, for example, X company, we have somehow they have a digital platform. So you can say, okay, they have this system. But now this system is, I mean, the world is moving a little bit ahead. I mean, the question is not only the digitized system or the database, the question is that how properly we can analyze the data and manage the data. So nowadays, if you look to, for example, people can say, okay, now in XYZ company, not the big companies, for example, the major oil and gas companies, they are very working on a fast track on digitization, and they are much more advanced. And definitely, as in the last presentation, I discussed with Iqbal Sifra Saab that, okay, yeah, of course, they are working, but not all the companies are working like them. So now in lots of companies, we have the digitized systems, but somehow it is important to see how the digitized system is, working. Are they just working to just save the data and just pull out the data? For example, if I have 100 wells in my X software, And Farooq Saab tell me, okay, Jawad, I need the information about the those wells in which the water production is very high. So I will go as a reservoir engineer and I will look individually to the wells. This is my, I will go through 100 wells. And, okay, this is the GOR ratio, this is a water oil ratio, and blah, blah, blah. So this is a tradition. So I'm exposing myself to a traditional digitized system. And after maybe after 2-3 days, I will come up with the data sets and I will tell Farooq Saab, okay, these are the wells, and I think the production is going to be increased and it looks like increasing. So it will take lots of time. But on the other side, if I have artificial intelligence system, I put all my 100 wells and the machine learning, every field is different. So this is very important. In the last discussion, I like it. People ask many questions. They said, Jawad, the companies are working on this project. They are very, I say, no. The company who are working on the Gulf of Mexico, they cannot work on the data sets we have in North Dakota. The companies they are working in the BB, for example, the companies are working in North Sea, they cannot use those algorithms in Pakistan for the North division because we have different, stratas are formation in the North region. It is very difficult to drill a well in North region as compared to North Dakota. In North Dakota, they drill a well 20,000, feet of well in just 9 days. And it's like very fast drilling they have. So but they might not be able to drill the well fast like this in North region. So the question is, and the answer and the question is actually that how better you manage data, and then how. So I was talking about the artificial. So if you have artificial intelligence system and I just click, and it depends upon the engineers and the managers and the company structure, how they want to expose themselves to the data, what they want. For example, when I was a company, so they call a meeting and they say, okay, today we have problems in these 10 wells. So what to do? So we brainstorm with the petrophysicist, geologist, petroleum engineer, drilling engineer, with the reserve and economics, and we make decision. Okay, now we have, and the water production is going to increase. This is Edgewater Drive. We want to just do the cement squeeze job, stop the water production, and improve the oil. So that's it. So, and then we want to see the cement bond. If the cement bond is okay, we can run the PSP. We can see, okay, the contribution of water, oil, and gas, and that's it. And then we say, oh my God, we stop the water because the water is coming from the, from the lower perforations. It takes time. So on other side, if you have artificial intelligence system, and Farooq Saab, are you understanding me?
Yeah, I'm listening. Here. I was thinking about using the SQL queries. We were using the SQL queries to get this type of information. So I think this is more advanced than that one.
So
Like finding the water, like finding the highest number of water cut wells or highest number of production, with
yes.
simple things like that. Yeah.
Yeah. So thank you, Farooq Saab, for mentioning it. I will jump into that. So I'm trying to go a little bit deeper in this subject. So Farooq Saab, I mean, you are right. I understand your point. I will talk about it when I will discuss the real time, case study. And so now it will take lots of time to find out my water cut, and as you mentioned SQL, and it will say, okay, you have now these wells. But now if we have artificial intelligence system, can the artificial intelligence system give me alarm that the out of 100 wells, the 15 or 20 wells will be water out in the next 20 days? This is actually the magic of artificial intelligence. And it depends, I mean, the water cut of your field. It depends upon how you train your algorithms. It depends upon the data. So this is actually the most important thing to, to train your data sets and then, extract meaningful information. For Farooq Saab, I think everybody please mute yourself. I don't know. Let me see if I can do it from here. I can do it from here. I can do it from here. Okay, I muted one of my friend. Okay.
Okay.
Muted. Okay, thank you. So now, Farooq sir, coming to the point, I mean, of course, if we want to approach to the data and if we want to approach the real-time water cuts at everything, so definitely we need sensors, and that sensor will give us real-time data, and then we can manage the data, and we can, it will go through the algorithm and it will give us information. So this is again, I mean, offshore oil and gas companies are facing the challenge in terms of downtime, which is about 27 days, about 4 weeks per year, and which can cause annual losses of vary from USD 38 millions to USD 88 million. So due to the mismanagement, the poor data sets, poor, systems, they are facing this huge problem till now, and they are losing $38 million per year. It's a huge amount. Farooq sir, this is your question, which we asked, can we do like unstructured data directly? So I think this is very important to understand data challenges. Volume, velocity, variety, variability, and visualization is very important value. And then data acquisition and data mining and cleaning. So, I mean, this is the life cycle of actually the data. And this life cycle is very important. Once you're going to train your machine learning algorithm, this is very important to, work on the data and different aspects.
Yeah,
About
because
50,
unstructured data is a challenge, Real challenge is to uh, extract data which is unstructured and use that data.
exactly. And Farooq Sahab, I'm coming to in the case study today. I will let you know how many challenges they have faced when they were cleaning out the data and they were structuring the data. You are absolutely right.
Thank you.
And now about 50% of 560 enterprises think big data will help them in increasing operational efficiency. According to the liberal estimate, big data could produce $300 billion, about 920 per person in the United States annually in the healthcare, and 250 billion pounds for the European public administration. Data business in the oil and gas market expected to be valued 145 billion by 2032 world oil. So this is, I mean, we can understand the importance of big data in the coming days, specifically in the next 10 years. So this is the amount of, money they will generate from the big data. So it's a very, very hard issue. And now it's important today, everybody in this presentation, we are 16 people, everybody, I mean, must think about it, how we can be part of this digitalization and how we can work. So this is actually, the barrels of oil lost daily due to downtime by the global average. So this is also important to see due to the data or the data management systems, we are losing lots of oil. And now this is slides I also explained very well. So I don't want to spend lots of time again on it. And I'm also looking to the time. Farooq Sahab, how much time we have?
Jawad, do you want me to make a link for extension?
No, I have already, my Zoom can, we don't need to.
I think Jawad has indefinite time, but we will
Okay.
spend another maybe 10 minutes or so, then we can start asking questions,
Okay.
involve
Okay.
everybody.
So just, so I will keep in my mind 15 minutes, Farooq Sahab.
10-15 minutes, yeah.
Okay, let me do it and that time spent to complete the presentation. So we talk about the artificial intelligence is the branch of computer science in which the intelligent machine can behave, think like humans, and are able to make decisions. This is only possible when a machine can have a human-based skills, for example, learning, reasoning, and solving problem. The author Samuel actually defined, this is very important definition. I will go through it. It's a very, actually the author Samuel in 1959 in MIT introduced artificial intelligence system. And then Tom Mitchell defines machine learning by saying a well-proposed learning problem is defined as follows. He says a computer program is said to learn from experience E with respect to some task T and some performance measured by P. If its performance on T is measured by P improves with experience P. So you can see it on the internet as well. So this is actually the introduction about the, and then we have different artificial intelligence system, the expert system. The system does not use traditional programming for solving complex problem, but it uses logical notation to achieve objective. Its main application applied in the medical sciences. And then the robotics, the branch of artificial intelligence ready to design and develop of robotics. Application of robotics is to deal with the designing, constructing, and operating of robots through the science and engineering techniques. So in the oil and gas industry, for example, it can be used in the emergency situation. If you have a leakage in the pipelines, so your robot can perform very well. So instead of human beings, it can also deal with the bulky, objects, and also they can perform. For example, NASA also uses it for moving heavy objects to space. So the robots are also playing a very good role in the oil and gas industry. Machine learning actually using enough data, machine uses to learn from the data, and makes their own decisions. The system processes, analyzes, and interprets data to tackle real-life challenges. Machine learning algorithms are used to predict future outcomes based on the vast data sets. And then, the most important thing, 23% of the business haven't identified the right software and algorithms for their AI solution. This is the, according to the IDC, 23% of the businesses haven't identified the right software and algorithms, and 77% feel limited by their infrastructure. The key element for successful AI artificial intelligence strategy should be an integrated approach to the hardware, software, and data. So, Farosa, this is very important. Again, we are saying about the AI strategies. So, a proper approach to the software and data is important. Speed and flexibility, and the right software and algorithms. So I don't want to go into details again, fuzzy logic, neural networks, system related to the use of neurology, which integrates cognitive science to help computer system and machine in performing numerous tasks. It's called deep learning because in this system, artificial brain neurons are used to solve the ambiguous problem. So I don't want to go into fuzzy logic, however, in many cases, a concept.
Yeah, we can go to the real-time example. That
Okay.
will be really good for us here.
Okay, Farooq Saab, let me go to that.
That we can discuss that example.
Okay, Farooq Saab.
Thank you.
So this is actually the presentation I presented in the SPE. So I already discussed it in the last, So a case study, application of the data management and AI ESP case study. So this is a real-time case study. An integrated hydrocarbon producer wanted to improve the reliability of electrical submersible pump and its upstream operation to reduce unplanned downtime and deferred production. Before engaging the two companies, the oil and gas company relied on the threshold-based system to monitor its fleet of 2,100 ESPs. Existing system, however, generated a high volume of false alarms and couldn't provide their failure cause analysis required to resolve alert quickly. Due to the constraints of the conventional monitoring system, approximately 20% of the ESP failed on the annual basis. This is the first point, Farooq Saab. The first point gives us an understanding in this case study that the traditional monitoring systems are not that much advanced. And this is a real-time example. And this is not something we call a small company. This is a very big company. I can't mention their name. So, 20% of ESP failed on annual basis is a huge money. So the most important.
I'm sure Iqbal Sir will have a lot of questions on this one. Yeah.
Yes. Okay. So, they were trying to resolve the issue of 2,100 ESPs, and due to the constraint of conventional monitoring system, approximately 20% of the ESP failed on annual basis. So enterprise AI for improving electrical submersible performance. So over 14 weeks, the company collaborated with the project managers and subject matter experts from the oil and gas company to develop a production-ready application to identify ESP anomaly events and provide operator with the early warning for 400 ESP across 2 operating fields. So now this is important. Some people say, okay, and when we are talking about the artificial intelligence, I'm petroleum engineer, I'm a geologist, how I work on this field, I am from IT, I don't know machine learning, I am artificial intelligence expert, but I don't know petroleum engineering. So what will we do? So lots of people are really confused on this topic. And I receive most of the question like this. So this is important. I saw people in petroleum engineering, they have a very good expertise in artificial intelligence. And even in the university, now we are studying artificial intelligence, and it's important. And if you learn Python and if you learn the machine learning, it's a very good. But if you are a petroleum engineer and if you have a concept of artificial intelligence and machine learning, so you can work together with the IT experts, with the artificial intelligence experts, and you can, bring something to the table. So, for example, if I'm artificial intelligence expert and I have PhD in artificial intelligence, but I don't know what a petroleum engineering is actually. I don't know what reservoir engineering is. I don't know how to make a decision about a work or job. I don't know how to efficiently drill a well. So we can ask this question vice versa from the artificial intelligence expert. Okay, Mr. AI expert, can you please tell me how can I better manage my reservoir? So he will say, no, absolutely no, because I have a PhD in artificial intelligence. I don't have PhD in petroleum engineering. So this is a gap. How we can eliminate this gap? Advanced companies are working on this topic. So what they are doing actually, this is the real-time example. What they are saying is actually the artificial intelligence experts and the company's manager work together, because the company managers, and the relevant people understand their fields. And every field has, they have different data sets and they have different problems. The problems of Gulf of Mexico, the problem of North Dakota, the problem of North region in Pakistan is totally different. The production trends in North Dakota, the production trends in North Sea and the Gulf of Mexico and Pakistan is totally different. So it's up to the people how they understand their data. So until and unless they don't understand the application of big data, the application of AI, its application, I don't think so they can play their role. So this is very important from this presentation perspective to work together and come up something, to resolve the issue. The team began by integrating, cleaning, and unifying 5 years of data from 9 different fields, and unified and federated data image. The unified data images comprise more than 50 million rows of data, including ESP sensor, production completion, perforation details, deviation surveys, productivity, and actually every data set they required, they actually got from the oil and gas company.
Jawad, just to interrupt, so when they made this application to give early warning for the ESP, this is to give the ESP to know the early failures of ESP, right?
Farooq, I'm coming to that. Yes, you are absolutely right. So the problem is the traditional monitoring systems are giving them false alarms. And due to the false alarm, they were facing a lot of huge problem, and they were using the traditional softwares and machines, So here, the company approached to the oil and gas company, and they say, okay, we are going to resolve your issue, no problem. We are happy. You will give us money, and we will give you solution. But there are some stages we have to work with you people. So they come up with their, data, and when they check their data, so they actually, got some data sets which we call it like production data, completion data, perforation data, deviation surveys. So this is very interesting point. I mean, they have artificial intelligence experts, but they are working on perforation details, deviation surveys, productivity, and whatever we have, the reservoir management data. So they now start working together. And what they found actually, the unified data images comprise more than 50 million rows in data, including ESP sensor. So now, I mean, in terms of revenues, like a 13 billion in revenue in 2020. I mean, the artificial intelligence system by doing this sort of, solution giving, and 1,700 millions of barrels of oil equivalent in the, in the reserve balance. So this approach, they actually added lots of, revenue to the company. Operator has operation in 4 countries and in investing between 100 million to 150 million in innovation and technology to accelerate digital. This is very important point, Farooq sir. If I am, and for example, if I have a company, or either I am working for my company, I'm oil and gas company, I'm a professional, I can ask this question from myself, from my company, from the management. Even we can discuss it with the management, or me myself as management, for example. How much money we are spending on the innovation and technology? Are we mentally ready to adopt the change? No, this is this again, I didn't mention it in my presentation, but this is again one of the most important point, that it is very difficult for the people to quit from traditional learning systems. And they don't want actually to adopt the change, drastically. So it is very important point. So now the companies who are adopting this change definitely are, moving towards it, and they are making the change. So now this is the company, they are investing 100 million to 140 million in innovation. And I was in the oil and gas industry. Whenever we do any job, so the first thing is to run the economics. If we are running a workforce job and we, for example, we want to fill out the tubing, we do the stimulation job. So if we don't have the sufficient reserve, or we don't have the, if we don't have the economics for that specific well, I think, Farooq sir, we cannot go for the workforce job, because we don't have the sufficient economics. Economics does matter. I will look at, for example, if I do this stimulation job, how much return of oil it will give me. Can it give me the revenue? Can it generate the revenue for the field or not? Sometimes you are producing oil and gas, but can we, for example, I saw lots of fields they're producing, but they're uneconomical or marginal fields. So I mean, this is important to say. So this important point shows, Farooq Saab, that the investment in the oil and gas and the digitalization is very, very important. Every company should think it seriously. For example, I mean, the companies, they're not working towards it. In 14 weeks from the kickoff to reproduction application completion, 5 years of historical data, integration comprising 5 years of historical data integration and comprising over 50 million rows in from 9 discrete enterprise IT system and 16 logical objects used to build an extensible data model to 50 times serial analytic. This was actually the methodology they were working towards it. 14,400 plus machine learning model premonition configured and tested to predict pump system. Okay, so now here they have work on more than 14,400 machine learning models towards, and Farooq Sahab, these models were trained to detect the failures and anomalies. So this is also showing that, to properly train the data, you need a lots of machine learning models. It's not like a traditional data management system and you can say, okay, I have this data management system, I can see my water cut, and that's it. No. I mean, artificial intelligence can make the difference. And I mean, they need to train a lots of model to properly detect the failure on time. And then configured reliability application user interference equipment details and failure data, allowing the company to leverage historical data from all relevant sources. Again, historical data they needed, and the team then utilized deep learning and unsupervised algorithms, so an optimal model to predict ESP failure and diagnose. So unsupervised, algorithms and, actually deep learning. Deep learning is a type of machine learning. I mean, they learn from the historical. Automatic car system is also like a good example of deep learning. So they learn from the historical data and they can properly predict the ESP failure and diagnose unhealthy ESPs. A global model was trained on historical ESP data, allowing the model to learn normal operating behavior over thousands of historical ESPs. The term leveraged the normal operating behavior established to identify anomalies, deviation in individual ESPs. So I don't want to go into detail. The team, they found a lot of complexity and they trained the model very well. And, what was the objectives of the project? Reduce the number of the false alarms generated by, threshold-based system, apply machine learning to predict ESP failure 20-40 days in advance. Also, this is the point which you told me earlier, to predict the ESP failure in 20-40 days in advance. And it gives them, 13 million additional revenue by reducing downtime and cost due to the ESP failure. 65% of ESP failure correctly predicted with 20-40 days in advance of failure. 50% of reduction in false positive alerts. Reduction in false positive. So this is the model.
This was the thing which I was thinking about, that these are really the advantages of this system that we got in advance, and it saved a lot of cost also.
Yes. But the important thing, Farooq Sahib, is important is like this company was working on, for example, on their 2100 ESPs. So, I mean, they can better understand and, manage their data. And you are absolutely right. I mean, this is the amount of, money they have generating from this problem. And it's a huge amount. I mean, it's not like, and as you mentioned, it's, if you predict something in 20 and 40 days in advance, I think it's a game changer. So Varosa, this is the C3 AI reliability machine learning model, and SCADA data, well test data, wellbore data, pull and install data, reservoir data, and this is machine learning, continuous data processing, blah, 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 and AI, and then infrastructure services. This is major application. They are saying we are not only working on the, upstream, midstream, downstream, but they are working on all sectors exploration. For example, I was asked a question, okay, how we can use the artificial intelligence when we are drilling a well? This was very interesting question for me, but then I given them an example of one of the company working for, I'm talking about EDNOC and how they are working on the, advanced digital technologies to properly zoom in the strata and structure the rock and properly classify the rocks formation. Because once you better understand your strata, you can better plan for the drilling. And even another company in Ghana, they properly train the artificial intelligence system to better drill the well. So, I mean, we can use, it's not limited to only exploration or upstream, midstream, downstream, but they are working on all these sectors. So recommendation, proper and real-time decision-making will improve efficiency and avoid misleading decision-making. Petroleum engineer will see real-time information to make timely and more precise decisions. Data acquired from machine learning programs should be properly cleaned, organized, and trained to obtain the best results. Oil and gas companies are spending 3 times more time searching different data sets for decision making. For better and quick decision, it is indispensable to convert all structured data sets contained in different domains using state-of-the-art technologies. The most important step for oil and gas professional is to understand the trends in the different data sets to apply them to make appropriate decisions. Big data sets can be easily converted to make key decisions using big data analytics. Structured data set could be shared and stored and processed in the proper way to leverage performance. Thank you very much, Farooq Saab and all.
Great, Jawad, that's
you,
a
Jawad.
great presentation and a lot of details in it, and looks like very difficult for most of us to comprehend everything from your presentation. But I think we will continue efforts. We will call you back again and again and again till such time we will start understanding this thing. So anyway, the floor is open for all kind of questions. Please raise your hand in order to ask the question.
जी
I
मैं
just
बोल
want to
सकता हूँ
thank Jawad. This was very informative for the real-time example which you gave for the ESP, and that was really nice. And we can understand now. We are slowly as Yasir said, we are slowly understanding that this how it works, and now it's really we are now a little bit used to. Now we are getting used to how it works, right? Thank you.